All right, for the next problem, if we want to figure out what the center is, we would say that this part right here would be like x over 3 minus 0. And so for this one, the center is 0. And then we are going to go ahead and figure out what the radius is and what the interval is. So if you look at this problem, you can recognize that this is a geometric series. And so that means that it converges if the r value is less than 1. And so I'm going to go ahead and just write these as notes down. So it's going to converge if the absolute value of x over 3 is less than 1. And so that's going to, I'll go ahead and multiply that 3 over. If the absolute value of x is less than 3, then it will converge. And so that means that the interval, or the radius of convergence is 3. And so the interval of convergence is from -3 to 3. And so just like before, we have to test the endpoints and see if those work. So I'm going to go ahead and check -3. So -3 over 3 to the n is going to be -1 to the n, which will just be alternating between -1 and +1. And if you think about this one, that's kind of like the nth term test. And so if I did the nth term test, I'd say the limit as n goes to infinity of -1 to the n, and it would alternate, it'd be plus or minus 1. And so the conclusion there is that it diverges. And then we would also, that means we're not including that one. Okay, so then we would also test +3, so 3 over 3 to the n. That is just 1 to the n, and so again, if we do the nth term test, the limit as n goes to infinity of 1 to the n is just 1, and since that is not 0, then our conclusion is that that one diverges as well. And so that means that our interval of convergence would not include either endpoint. Okay, let's go ahead and try this next one. So here, sorry, I gotta get my notes out, make sure I have everything. There we go. So here, if we think about what would have been in the parentheses with the x, just like before, it would have been just like this one was x over 3 minus 0. This one would have been x minus 0, which is why it didn't have any parentheses. And so we're going to say the center here is 0. And then we also want to find the radius and the interval. And so this one is kind of back to what we expect. It's a ratio test, which is pretty typical for these problems. And so I'm going to go ahead and do the ratio test. So I'm going to go ahead and leave out the -1 just because I know that that's not going to do anything. So I'm going to say the limit as n goes to infinity of x to the 2 times n plus 1 over 2 times n plus 1 factorial divided by x to the 2n plus 1 over 2n plus 1 factorial. All right, and then I'll go ahead and fix this. So that's the limit as n goes to infinity, and I'm going to fix it by doing keep it, change it, flip it. So this is x to the 2n plus 2, and then plus 1 more, so that'd be 2n plus 3 over 2n plus 3 factorial times, and if we flip the other one up, that'd be 2n plus 1 factorial over x to the 2n plus 1. Okay, so if I think about how these would cancel, this one I could say is x to the 2n plus 1 times x to the 2, and that would give me 2n plus 3. And then, so that goes away. This would be 2n plus 3 times 2n plus 2 times 2n plus 1 factorial. And so now if I go ahead and look to see what would cancel, these two would cancel, and then these two would cancel. And so what I'm going to evaluate is the limit as n goes to infinity of x squared on the top over 2n plus 3 times 2n plus 2. And if I evaluate that, since I'm thinking of the infinity as going in for the n's, not for the x's, then that's going to be a limit of 0. And so that means that this converges absolutely. It doesn't matter what I plug in for x, it's always going to converge. So I'm going to say converges absolutely. And so when I go back then, that means that the radius of the convergence would be infinity because all of the x's would work no matter what they are. And so the interval is from negative infinity to positive infinity. All right, and then one more. So this one, the center would be 3. And we're going to find the radius of convergence, and we're going to find the interval of convergence. Okay, so here I'm going to go ahead and do the ratio test just like before. And so I'm going to do the limit as n goes to infinity of n plus 1 factorial times x minus 3 to the n plus 1 divided by n factorial x minus 3 to the n. And so we can do, I'm going to rewrite some things so we can do our canceling. So this one right here would be n plus 1 times n factorial. And then this one would be x minus 3 to the n times x minus 3 to the 1. And so if I cancel some things out, then I can see that the n factorials cancel, and the x minus 3 to the n's, those cancel. And so this gives me the limit as n goes to infinity of n plus 1 times x minus 3. And I could put that over 1 or not put that over 1. It doesn't really matter. But everything on the bottom canceled out. And so if I evaluate this with infinity, it would be infinity. And so this one's going to diverge. All right, but if we remember what we talked about at the very beginning of the video was that you have 3 different possibilities, and one of the possibilities is that you have the radius of infinity where every single x you plug in could converge. The next possibility is that you have a radius of a number, and so only numbers in between there, when plugged in for x, would make a converging series. And your last option was one where this part would diverge, and so that means that only the center would converge. It's not possible here to have one that just doesn't converge at all, but it is possible for it to have a radius of 0, and to say that there's not really an interval where it converges, that it only converges at one value, and that that value is the center of convergence. And so here it would converge for one number, and that's if you plugged in 3. That's the only way it would possibly converge. Okay, and so just in general, I want to make sure that we're understanding what this interval of convergence really means. And the interval of convergence is just saying if you picked x values that are on that interval and you plugged them in for x, you just used them as a number, then we could transform ourselves back to that last unit, like go back in time and go back to the last unit we did, and we could do a series test on it and it would converge using that number for x. So for this one, if I used an x value of 2, and I did 2 over 3 to the n, and I went back to my last unit, and I said, does that converge? Does that series converge? You'd say, yes, it's geometric, that's 2 over 3. If I did -2 or -1, and we went back to last unit, you'd be like, yep, that converges. If I picked a value outside of the interval, like the number 5, and did 5 over 3, last unit, you would have looked at that, and you would have said, no, that does not converge. Okay, similar for this one says no matter what the number is that I plug in for x, it's always going to converge. So here if I picked 900, we could go back to last unit, stick a 900 in there, and do the testing on it and say, does it converge? And your conclusion would have been yes. So that's what we're doing when we find those intervals of convergence, is we're saying we have a variable in the problem that we did not have last unit. In this unit, we're saying what numbers could I plug in for that variable x that would allow us to go back to last unit and conclude, yes, that series did converge.